Welcome to the deep dive. Today we're looking at something, a platform that's engineered to solve what is really the core dilemma of blockchain technology.
Really?
How do you achieve that massive speed, that scalability, but at the same time, maintain absolute ironclad security?
That tension is the problem every developer is staring down right now. I mean, traditional blockchains, they just demand this total ordering for every single action.
Like one big global queue.
Exactly. A single queue for the entire world. And that's slow, it's resource intensive, and it just fundamentally limits what you can build. You get congestion, high latency, the works.
So the system we're diving into today, the SUI platform, is basically promising a way out of that queue. We'll be looking at its core engine, SUI LUTRIS, and its specialized programming language Move, and maybe most importantly, how big institutional players like SUI Group Holdings are reacting to all this.
Right.
The mission is really to understand how they plan to deliver on that promise of finality in, under 500 milliseconds?
And that half-second benchmark, that's transformative. It's not just a little faster. It moves blockchain from being just for slow, asynchronous stuff into a realm where, real-time applications become possible.
Like high-frequency trading or?
High-frequency trading, complex online gaming, things that are sensitive to latency. It completely changes the calculus for institutional adoption.
Okay, so let's start with the architecture that gives the system room to breathe. Parallelization. We've used the analogy before of a single-lane road. How does SUI turn that into a multi-lane superhighway?
The key is shifting focus. You stop thinking about just executing transactions one by one, and you start thinking about managing the underlying state of the whole ledger. And, well, a lot of chains are trying to do this, but they're taking very different routes to get there.
So what are the main paths they're exploring?
The first major method is what they call the optimistic model.
Optimistic, okay.
Yeah, and you see this with networks like Monad and Aptos.
Yeah.
It's pretty simple in concept. You just let all the transactions run in parallel, and you sort of, just assume they're independent.
You hope for the best.
You hope for the best. And if a conflict comes up later, if two transactions accidentally touch the same piece of data, the system then has to go back, verify it, and maybe rerun things.
So it's simpler for the developer upfront, but you're kind of betting that there won't be a lot of conflicts.
Precisely. You sacrifice predictability. If there's a surprise surge in activity around one asset, that optimism suddenly becomes a bottleneck.
And the other method?
The other method is the state access method. This is what SUI and Solana use, and it's proactive. It forces every single transaction to declare right up front exactly which pieces of the state, which digital objects it plans to touch.
So as a validator, that seems incredibly powerful. You know everything in advance.
It is, because it lets the system spot true dependencies instantly. If your transaction is only touching objects you own, and my transaction is only touching objects I own, the system knows they're independent.
No overlap.
Zero overlap. They can be executed at the same time on different cores, no risk of conflict, and you don't need all that overhead of checking for problems after the fact.
And I imagine that transparency also helps with managing fees, especially when demand spikes.
That's the dynamic gas market benefit.
Yeah.
Exactly. Because the network can see dependencies, it can also spot hotspots.
Like a huge NFT drop.
A huge NFT drop is the perfect example. That contract becomes a hotspot. The system can isolate that congestion. So transactions trying to hit that specific contract might get charged a bit more, while totally unrelated transactions just sail through on other cores without paying surge pricing.
So the penalty is granular. It's not punishing the entire network for one popular event.
Exactly. On SUI, transactions go into checkpoints first come, first served, but then the ordering inside that checkpoint is based on the gas you provide. Getting that kind of fine-grained control is just so much harder with an optimistic model where you're always looking over your shoulder for conflicts.
Okay, so parallelization gives you the scale. But that raw speed, that sub-second finality, that has to come from somewhere else. It requires bypassing global consensus when you can. How does their hybrid protocol, SUI LUTRIS, make that call? When to go fast and when to play it safe?
It does this by splitting assets into two main categories: owned objects and shared objects. This simple categorization is really the secret sauce that unlocks that speed.
All right, break those down. An analogy would be great.
Okay, think of an owned object like a personal letter in a sealed envelope, only you have the key.
Right.
It's an asset, like an NFT or just your token balance, that's controlled by a single address. Since nobody else can touch it, there's no risk of a conflict.
So it doesn't need to get in that global queue.
It doesn't need global consensus at all. For that, SUI LUTRIS uses what they call a consensusless agreement path. It's a Byzantine consistent broadcast. The validators just check that the transaction is valid and that you, the owner, signed off on it. And they agree almost instantly.
And how much faster are we talking about here?
I mean, it's a night and day difference. For these owned objects, finality is achieved in just 2 network round trips. The internal tests they ran showed latency under half a second. That's up to 15 times faster than waiting for their own Bullshark consensus baseline.
15 times.
And look at the volume. On one peak day, July 27th, 2023, the system processed over 65 million certificates.
Wow.
The claim was that was more than all other chains combined on that day. It just shows the raw capacity.
That is just staggering performance. But of course, you can't get rid of consensus completely. What happens when we go from the personal ledger to, say, the public bank vault, the shared objects?
That's the safety path. That's when you bring in the full power of the Bullshark protocol. Shared objects are things like a big DeFi lending pool, or any complex smart contract that multiple people need to interact with at the same time. For those, you absolutely need global consensus to agree on the exact order of operations.
So they only use the slow, heavy machinery when it's absolutely necessary.
That's the whole point. Don't pay the cost of consensus unless you have to.
You mentioned a subtle point there, finality versus settlement. They're not the same thing.
They're distinct, and that separation is critical. Transaction finality is the moment a quorum of validators says, yep, this transaction is valid and it's going on the ledger. It's mathematically irreversible.
Locked in.
Locked in. Settlement is when the transaction has actually been executed and the result, the new balance, the new state, is known and can be used by the next transaction.
And that separation is what delivers the speed.
For the fast path with owned objects, finality and settlement are basically instantaneous. The guarantee is the result. For the safety path, finality still happens fast once the certificate is accepted. You get that guarantee of inclusion quickly, but settlement has to wait for Bullshark to sequence and execute it.
Okay, that makes sense. But one potential issue with these kinds of designs is, what if something goes wrong? Can an asset get permanently locked if a user's wallet messes up?
Yeah, a client double spending or something, that's handled by their reconfiguration protocol and this idea of liveness recovery. So in older systems, if your wallet had a bug and tried to double spend, it could potentially lock that asset forever, a disaster.
Right.
SUI uses its epoch boundaries as a sort of managed reset. If an object gets mistakenly locked because of a client error, it automatically gets unlocked at the start of the next epoch. It prevents permanent deadlock, which is critical for network health.
Okay, so we've got the hybrid architecture for speed. Now let's talk about the language they built on top of it. They didn't go with Solidity or Rust. They built something new. Move. Why create a whole new language?
Well, Move was actually born at Meta for the Diem project, and it was created precisely because they felt existing languages were, frankly, not suitable for handling high-value digital assets. The whole philosophy behind Move is what they call programming with scarcity.
Programming with scarcity. That sounds like the opposite of most computer science, where you can copy data infinitely for free.
It's the exact opposite. Move defines an asset as a first-class resource. This is a concept from linear logic. It means the language syntax itself makes it impossible to copy an asset or to accidentally delete it. It can only be moved from one place to another.
So scarcity is built into the grammar of the code.
It's built right in. That prevents so many vulnerabilities you see in languages like Solidity, where an asset is often just a number in a database table. If the code around that number has a flaw, you can manipulate it.
That seems like a huge safeguard. What about automated tools? What's built in to enforce all this?
2 main layers of protection. First, you have the bytecode verifier. This is a tool that runs on-chain. It does a lightweight but very thorough safety check on the compiled code before it ever executes.
So the network itself is double-checking the code's integrity.
Exactly. It verifies type safety, memory safety, resource safety. It means you don't have to blindly trust the developer's compiler, which can be a weak link.
And the second layer?
The second layer is more sophisticated. It's the Move Prover, or MVP. This is an off-chain formal verification tool. A developer can use it to mathematically prove that their contract's logic is correct.
To mathematically prove it?
Yes. Instead of just having human auditors look for bugs, the prover can give you a mathematical guarantee that, for example, your lending protocol can't be drained. It's a huge step up.
And what about the big one, the reentrancy attack that caused the DAO hack on Ethereum? How does Move stop that?
That's down to a design choice called no dynamic dispatch. In the EVM, a contract can call another contract, which can then call back into the original one before it's finished its first job. That's the reentrancy exploit. Move just doesn't allow that. All execution paths are determined statically at compile time. It's architecturally impossible to have those kinds of recursive, unexpected calls. It just eliminates that entire class of bugs.
That is a massive safety upgrade. So, okay, we have the tech foundation, incredible speed, incredible security. Now for the ultimate validation, institutional money. Why is a group like SUI Group Holdings making such a massive bet here?
Because they didn't just buy some tokens. They completely recentered their entire strategy around the SUI ecosystem. When they bought over 100 million SUI tokens worth more than $330 million and then rebranded, that signals an extremely high conviction bet.
They're not just a passive holder.
No, they're explicitly following the playbook of what they call digital asset treasury companies, or DATCOs. But instead of just holding Bitcoin as a reserve, they're betting on the utility of a high-speed, scalable network.
They're betting on the future use cases.
Exactly. They believe SUI's architecture is what you need for things like AI and the next generation of DeFi. And that holding isn't just sitting there. Their staking yields, around 2.2% APY, are generating something like $20,000 a day in passive income.
Wow.
Which is a pretty healthy cash flow to fund their other operations.
And tell us about those operations, the SUI Bank idea. What does that signal?
The SUI Bank plan suggests they want to be the core liquidity engine for the whole ecosystem. This isn't just another lending app. They're talking about a central, compliant, and really robust hub for large-scale institutional services.
So proper lending insurance.
Exactly. Lending, liquidity provision, insurance products. The kind of infrastructure that big financial players need before they'll feel comfortable bringing serious capital onto a chain. It's a bridge from raw tech to a real financial marketplace.
That's a huge driver for the token's value. But of course, an investment this big has risks. What are the main red flags the sources mention?
The primary risks are really market volatility and regulatory uncertainty, which isn't unique to SUI. The token itself has had pretty significant 30-day volatility, between 16 and 21%.
But they seem to be weathering it.
Well, that risk is buffered by the ecosystem's really fast growth.
Yeah.
They reported over $1 billion in TVL in the first half of 2025, and they have key institutional partners like Galaxy Digital, which adds a layer of professional custody and backing.
So to wrap this up, what we've really explored today is this three-pronged attack on blockchain's biggest problems. You have the hybrid architecture of SUI LUTRIS for speed, you have the move language for safety by design, and you have these big institutional players validating the whole strategy with hundreds of millions of dollars.
I think the synthesized insight here is that the future of Web3 might not be about endlessly tweaking these older general-purpose languages that we sort of retrofitted for blockchain. The argument for Move is that when you create a new language from scratch, one that treats assets as scarce resources from the very beginning, you just eliminate entire categories of bugs and bottlenecks that are baked into the legacy EVM world. That specialization is what enables predictable performance and, ultimately, institutional trust.
Which leaves you with this final provocative thought to consider. Given the demonstrable boost in performance and the enhanced safety features that come with these new purpose-built platforms like SUI, will the industry's reliance on the dominant but aging EVM infrastructure eventually shift from being the engine of Web3 to becoming its greatest bottleneck?